Alright, so for this video, we're going to talk about sketching a graph. Now, following the previous video, which was introducing and explaining the parabola or the quadratic function at the grade 10 level, we're going to try and sketch a quadratic graph. Now, how do we know this is a parabola? It's because we have an x squared. Right, so when you have an x squared as the variable with the highest power, so you got x to the power 2 as the highest exponent no matter what else stays in the equation, this is now considered a parabola. Okay, so this is a parabola. Now, when sketching graphs, they don't mean to do a table of ordered pairs and do all of that. No, we don't need to do all of that. What we need to do is we need to know the shape of the graph, which is why we introduced the mother graph first for all of our graphs. So we need to know the shape and how it's affected by the various parameters. So for example, for the parabola, we have y is equal to ax squared plus q. What does a do? What does q do? Right? So that's what we need to know. So based on that, we sketch our graph. So we need to know our shape, and we need to basically have two important points, right? Two important points, or basically all the important points, but at least two, right? Minimum. Your graph should have two things. If there's more important points, you should have those. If it's just one important point, you should only have that important point, and you just need to find one other point, right? So there should be at least 2 points in the graph. So let's begin with this one here now. From this, we have our value of plus 4 for q. This indicates a y-intercept of 4. And we have a positive a value, which indicates a happy face. So to sketch this graph, I need a Cartesian plane. So let's just draw one of those right here. Let's put a y and an x value, and now we need to mark the point we've chosen. So here we've only realized we had the y-intercept here. Now in a happy face graph, all right, the turning point of the y-intercept happens at the bottom, as we've seen in the previous video. So this means our graph is going to look something like that. Okay, something like that, right? And it passes through the point 4, the y coordinate of 4. Now remember, I said you need at least 2 points, so we're gonna find one more point. We can find the point f of 1, so we just substitute 1 into our equation, or rather let's do f of 2. Okay, so let's do f of 2, so it's equal to a half 2 squared plus 4, which is going to be 4 to 6. All right, so we're going to have the coordinate 2 and 6 on our graph. Once you've got the correct shape and you've got two coordinates, you are done. All right, let's move on. Let's try this one. So again, we have this and we have this. The negative in the front tells us we have a sad face. The minus 1 tells us the y-intercept. So Cartesian plane. Alright, so y-x. It's gonna go through the y-intercept of minus 1. So let's just go ahead and put that there. Alright. Okay, so it's something like that. Alright, so it goes through there. Alright, so it's somewhere there. And we need one other coordinate, so let's find f of 1. So negative 4 into 1 squared minus 1. So f of 1 is equal to negative 5. So it should be somewhere along here. So 1 and negative 5. For this one, we realize that we have a positive value here indicating a happy face and a negative value here for your y-intercept. Drawing our function x and y axis, our y-intercept is going to be here at negative 1. So let's just go ahead and draw a happy face that touches negative 1. Now, what you're going to notice about this function specifically that wasn't present in our previous functions is that this graph has x-intercepts. There are two x-intercepts. So if you look at the previous ones, there was no x-intercepts. The graph never touched the x-axis, even in this one. So it never touched. But here it's touching. So we can't give a random point the way we did before. We need to give these 2 points. We don't need to give any other points. It needs to be these important points. So how do you do that? Now, if you recall that when you want to calculate an x-intercept for any graph, you let y equal to 0. So in my function y equal to x squared minus 1, I let it 0 equal to x squared minus 1. This can be solved by using dots on the right hand side, and then we can say x plus 1 equals to 0, or x minus 1 equals to 0. So x has to equal to negative 1, or x is equal to 1. So my two coordinates are going to be negative 1 and 0. So negative 1 and 0, and 1 and 0. So why am I saying 0? Because these are coordinates were obtained by using y is equal to 0. And the x's are the two answers I solved for. So this is going to be negative 1 and 0. And this is going to be 1 and 0. Now that I've indicated all important points, I am done. You can just draw a little arrow on those to show that they are continuing. For the next one, definitely pause the video and try this. But anyway, first thing we notice, sad face and y-intercept. So sad face, y-intercept. Let's go ahead and put our axis into place. So starting with the y-intercept, we should get a positive 9 somewhere there. Drawing a sad face would look like this. Alright, so there's our sad face there. Again, we realize we have two x-intercepts, so we need to find those. So x-intercept, let y equal 0. So 0 is equal to negative x squared plus 9. We can go ahead and factor out a negative there. So you'll have negative into x squared minus 9. And then you can go and set negative. X squared minus 9 can be factorized using dots as x plus 3 and x minus 3. So then you can say x plus 3 equals to 0, or x minus 3 is equal to 0. So x has to equal to negative 3, or x has to equal to 3. In that case, it's going to be negative 3 and 0, and 3 and 0. So we should have negative 3 and 0 here, and we should have 3 and 0 there. And that will be my graph drawn.